Okay, so we're gonna do, let's not, we're gonna do the worksheet today instead of 17 through whatever we're gonna do. It's a little bit of a repeat, and then the new stuff that we didn't get to is gonna be on the second half. So the first part is state the possible rational roots. We did this part yesterday. Do you guys remember how this goes? What are the possible answers? Well, when they say roots, what are the possible x values that make this equal 0?
Are we not grading?
What are the zeros function? No. Okay, so remember what we did yesterday. It was factors of the last over factors of the first. So factors of 1 over factors of 3. What are the factors of 1? 1. What's the factors of 3?
1.
So it's 1 over 1, 1 over 3. 1 over 1 is just 1, and 1 over 3, 1/3. And remember, they can all be positive or negative. Starts off easy enough. Okay, x squared plus 8x plus 10.
If it doesn't have the second thingy, do we just put 0? Put like number 2.
Well, if you were doing synthetic whatever, yes, but we're not. You do the last coefficient over the first coefficient. Last coefficient is 64. First coefficient is 1. Lots of stuff goes into 64, so be careful on number 2. Anyway, so number 3, factors of 10 over factors of 1. What goes into 10? Pick up. So 1 over 2, 1, 2 over 1, 5 over 1, 10 over 1, so it's just 1, 2, 5, and 10, plus or minus.
Sorry, y'all. You didn't put plus or minus 10.
Numero 5, factors of 25 over factors of 4. What goes into 25?
1.
Yeah, 1 times 25, 5 times 5, and into 4, 1 times 4, and 2 times 2. So, it's 1 over 1, 5 over 1, 5, 25 over 1. And it's 1 over 2, 5 over 2, 25 over 2. They're increasing in intensity. Or frequency, that's the word I meant, not intensity. Okay, and then 1 over 4, 5 over 4, 25 over 4. So lots of options. It's actually like 18 different options. They're not going to be that mean to us though.
Oh yeah, you have to find the right one.
We're going to actually have to solve it, yeah, when we get down to 9. Number 7. I'm thinking of putting the camera on you, just watch you sit there and hiccup.
Did you just try and laugh and you hiccup? I heard
Grant's just gonna have to watch that. Yeah, you should do that.
that was funny.
Last year, Lydia was blind, I was going to put the camera on there.
Wow.
And That'd be got way more views than all the other ones. Okay, 7 is factors of 27 over factors of 1. You guys know what goes into 27? 3 and 9, and 1 and 27. And that's it. I still think they don't know what causes hiccups.
Isn't it just
It's like a spasm or something.
She hadn't eaten in, a long time.
what?
I think most of the time when you hiccup, you haven't eaten in a long time.
No, I said hours. Babe.
You ate like 2
I
hours.
was like,
Alright.
1 hour and a half, actually.
I actually I had some canned Cheetos.
Okay, number 9. So it starts the same. State the possible rational zeros for each function, which is the same thing as the roots. But then find all the rational zeros. In other words, we actually have to solve this one. So we're gonna have to learn a little bit. I tried to introduce this yesterday, but we'll go through the whole thing today. Okay, so it starts the same. What are my possible answers? Factors of 3 over factors of 1. So not a lot of options. 1 over 1, 3 over 1. All right, yesterday I mentioned how many answers normally should we expect in a cubic function? 3. Now that's not always true, especially on this worksheet. Sometimes there's what you would call a double root where the answer kind of works twice even though it only counts once, but yeah, normally we would expect 3 answers. So we want this to, if you close your mouth, you won't make as much noise when you go, just an FYI.
but then I feel like I'm gonna choke on it. I'll try this.
Choke on air.
That's weird. That's working.
It's all that air that's rushing through your throat that makes the noise. Anyways, so we want the values that make this equal to 0. That's specifically what we're looking for. The zeros of the function, the roots of the function. So how can I figure out if 1 is an actual answer or not? Well, you can just plug it in right here. Plug in 1 for x. If I plug in 1, what's 1 cubed? 1 squared is 1, 5 times 1 is 5. Plugging in 1 is kind of easy. Does this actually equal 0?
Swallow your breath.
Yes.
I heard you pinch your ears and pull them down.
Right.
Drink water.
Hold-
I don't have water.
Holding your breath does work, but you have to keep doing it like 2 or 3
No,
times.
hold it and then swallow it. And then
Just hold your breath, and then they'll slow down faster. They'll go way faster.
you just pass out and sit on your head.
Like you have to hold it for like
Oh
40,
wait, no wait.
45 seconds, then you'll have to get another breath and then start over. It does work, but it doesn't work immediately. Okay, does this equal 0?
Yes.
Yes, it does equal 0. So 1 is one of these zeros of the function, or one of the roots of the function. It's one of the values that will make the function equal 0. Okay, but should be 2 more. So we could keep plugging stuff in. The problem is sometimes the answers are not rational. Sometimes the answers are like, square root of 10. On this worksheet though, they are all rational. But I want us to practice getting the last couple answers in a different way. So, you guys remember back when last chapter when we were solving and we factored something like this? Like, if it said like x squared, let's see, what would this be? Plus x minus 6 equals 0. And we factor it, and then what would the answers be?
2 and
2 and negative 3. So if this thing has 3 answers, that means it should break down to like 3 factors, like, whatever. factor 1, factor 2, factor 3. Okay, if we know one of the answers, we know one of the factors. Like we know one of the factors is x minus 1. So what I'm basically doing here is I'm dividing one of the factors out, x minus 1. And what it will leave me with is the last two factors, which contain the last two answers. So I'm going to use synthetic division to kind of divide this one factor out. Okay, it might not make a lot of sense, but you guys will see the pattern here. I'm going to take one out of this, like synthetic division. One is a solution, and I'm going to take it out. So I'm going to use the coefficients, 1, 1, negative 5, and 3. And do the thing. Now, if it works, if one actually works, I should expect to get a 0 over here, because it should make the whole thing. You can think of it like the remainder is 0, or 1 makes the whole thing equal 0. Anyway, it should come out as a 0 if it works right. So if I add down, multiply up, you guys have seen this enough. I'm not going to go very slow like I have been. Okay, so this tells me 1 is the solution, which I kind of already knew from earlier, but it also tells me that my last two answers can be found in here. Do you guys remember what this stands for? This is the number, the x squared, right? X squared plus 2x minus 3. And I want the one that's equal 0. So today these should all factor, but if they didn't factor, you could also use quadratic formula, because we've got it down to an x squared now. So we can use our tricks from last chapter. But how does this factor? What multiplies into negative 3 that adds up to 2? What multiplies into negative 3 that adds up to 2? 3, negative 1. So what x values make this equal 0? Okay, negative 3 and 1. 1, I already knew was an answer, so it's kind of an answer twice. So it's called a double root, but basically it counts for 2 answers, even though. So we're not actually going to get 3 answers on this. On most of these, there's double roots actually on most of this assignment.
Wait, how do you know which method goes in the box?
Well, these are my possible answers, and I plugged 1 in for all the x's, and I found out it was equal to 0. So I knew 1 was going to be an answer.
So instead of doing that, could you just do like in your calculator as like +3, or if it doesn't work, then do it as -3, and then you have answers?
Instead of doing this part.
Yeah.
Or
would you?
On today's worksheet it would work, but the problem is sometimes the answers aren't going to be this. So I want us to practice these steps later for when it's going to get harder later. Yeah, so go ahead and use synthetic division for today. She said, can we just keep plugging these numbers in until we find everything that works? Yeah, kind of, but go ahead and do synthetic. Yeah, that took up a lot of room, didn't it? All right, number 11. By the way, with the other class, we only ended up going to 16, so. Number 11. Okay, so how we started was find the possible rational roots. Factors of 2 over factors of 1. Not a lot of options. They're being nice to us. Yeah. Oh yeah, I'm glad you remember because I didn't. like to leave at 2:30 or be there at 2:30? Let's just have you leave a couple minutes before 2:30. Okay. Oh yeah. So usually before I do the synthetic part, you could try the numbers using synthetic, but I like to just plug numbers right here to see if it equals 0. I know 1 is not going to work because all of these terms are positive, so it'll just get higher and higher. There's no way it'll equal 0. But if I plug in -1, -1 cubed is -1. -1 squared is 1 times 4 is 4. 5 times -1. So that makes -6 with the negatives, +6 with the positives, and that does equal 0. So -1 is a 0 of the function. It does work. So that's one of my answers. Wait, what did you guys see?
The origami, Alex did choose for you.
That's where I was. Why did they?
Because it was free.
Yeah. That's interesting.
They were complaining about it. in
Wait,
class.
was it a football game?
Basketball game.
No. Yeah, I don't think you would have. Okay, so Ava, you're gonna be kind of lost here. A little bit. Some of the stuff we did is from yesterday. So add down, multiply up, all that jazz. All right. So what this stands for is x squared plus 3x plus 2. And I want it to equal 0. So what multiplies into 2 that adds up to 3? 2 and 1. So the x values that make this equal to 0 are -2 and -1. So -1 again is a double root. So there's only going to be 2 answers instead of 3. Okay. I'll try to kind of reteach it on 13. Ava. Actually, instead of 13, I want to do 14 because 14 actually does have three separate answers, unlike the other ones we did. Unlike 13, I think 12 did too. 12 and 14. So I want to look. I'm going to do 14 instead. Just make sure you guys see one of those. Plus 11x squared. Plus 11x minus 2. All right. So Ava, do you remember how we found the possible rational roots yesterday? Okay, it's factors of the last one over factors of the first one. Remember that? So it's factors of 3 over, and this one, they both happen to be a 3. So what's factors of 3? What's factors of 3? So it's 1 over 1, 3 over 1, which is 1 or 3. And by the way, Ava, this is the first 8 questions. You just stop after this part. So it's like yesterday's. But it's also 1 over 3 and 3 over 3. So 1 over 3 is 1/3, but what's 3 over 3? 1, which we already have. So we don't need to write 3 over 3 down. These are the possible rational roots. Okay, a root is or a zero, I think this paper calls it a zero, is a value that makes the function equal 0. So we can see if these are actual answers or not, actual roots, if we plug it in and does it actually make it equal 0. If I plug in 1, does it work? 1 cubed times 3 is just 3, so it's kind of easy to plug 1 in. I don't know if you guys have figured that out yet. Does that equal 0? No, it does not. 1 does not work. Let's see if -1 works. This would be -1, -3, plus 11. Yeah, I think that one does, because this is like -11. Okay, so -1 is a solution, is one solution. So what I'm going to do, Ava, basically is kind of like dividing out the answer that I know that works from this. And that'll help me find my last two answers. So I'm using synthetic 3, 11, 5, -3. So remember, it was add down, multiply up. And if it actually does work and we do it right, the answer that does work, the remainder should come out at 0. Okay, so remember when we divided, that this stands for the number, the x term, and the x squared term. And that stands for the remainder. But the last two answers are going to be found in this quadratic equation. Because it's only an x squared equation, we actually have tricks for that, factoring and quadratic formula. So you could use quadratic formula. I'll tell you, sometimes you have to use quadratic formula, but all of today's should actually factor. What has to go in the front? What goes into 3x squared? 3x times x. And in the back, what goes into -3? Like 3 and -1. So we have to put it in such a way that the FOIL outside inside adds up to 8. If I put my 3 out here, that makes 9x. And then the -1 right here, that'll bring it down to -1x. So that'll make 8x. Okay. Now, if that's how it factors, you guys remember how this works? My answers are -3 and +1/3. Okay, but didn't I say there was 3 answers on this one? Yeah. So yeah, that thing up there was an answer. It's just the first time that hasn't repeated itself. So yeah, -1 is also a solution. And you could check your answers. You could put them up into the original thing and make sure it works. That'd be a lot of work, but. Okay, are we good on that one? Okay, we're saving the best for last, and by best I mean the worst. So, what's different about 15? It's a fourth power. Fancy word for that is a quartic function. And this is gonna make it more difficult. Because the problem is, after I take out one answer, I'm still going to be left with an x cubed, a cubic. So I can't use my tricks yet. So we actually have to take 2 answers out before we can use our tricks. Okay, starting the same. Factors of 7 over factors of 5. Factors of 7 over factors of 5. 1 over 1, 7 over 1. 1 over 5, 7 over 5. worst thing ever.
It is.
All right. You got a tough life, Will. I'm sorry for you. Let's see. If I plug in 1, does it work? I think it did, if I remember right. This would be 5 minus 46 plus 84 minus 50 plus 7. My positives would add up to 96. My negatives would add up to negative 96. So yes, it actually does equal 0. So 1 works. So what I'm going to do is, kind of like the last time, just take a 1 out. They're kind of being nice to us because they're like letting 1 or negative 1 be an answer. I guess with the calculator it's not that big a deal either way, but
What situation in life do we use this? Good question.
Well, to be honest, there'd probably be, if you had a job that would need to find something like this, you'd probably want a graphing calculator to do it. There's technology ways to do it.
So then, never do learning this.
Well, okay, here's the problem. Remember earlier how I said like square root of 10 is an answer sometimes or something like that? Even graphing calculators can't quite do that. No, I'm being serious. No, you can't. The graphing calculator would just give you a big decimal thing. Okay, so everything in math, this would be like for engineering or sciences or stuff like this. But you guys probably mostly won't do it, but still they expect us to learn it, so sorry. Suck it up, Buttercup. Okay, so here we go again, adding down, multiplying up. Okay, so the problem is our leftover here, that's a number x squared, x cubed. And we don't have the tricks to solve an x cubed. So we need to find another answer to take out of it. Okay, that's what we got so far. So we need another answer. So you can plug in like 7, negative 7. Probably want to use your calculator for that. Plug in negative 1. In the other class, here's the other thing though. It's possible that 1 is an answer more than once. And if you plug 1 in for these, it actually does work again. So 1 is a double root. So I'm going to take the 1 out again from this.
Are you doing
Running out of
17, or
space.
can I use that for space?
Yeah, we're not doing 17 and 18, so if you want to use that for space. Okay.
Do we have to use this trig on 16 too?
Yes, because it's a x to the 4th thing. So you have to kind of plug in and find 2 different things that work. So in this problem, 1 is a double root because I took it out twice and it worked both times basically. Now we've got it down to a quadratic. And it does factor. Well, what has to go in the front? What goes into 5x squared?
We're going to hear about this in the group.
5x times x. What goes into 7? 7 and 1. I need to get to close to 36, negative 36. So I'm going to put a minus 7 out here to make minus 35. And a minus 1 in there. Make minus 36. So what x values would make this equal 0? 7 and 1/5. And 1. Don't put 1 twice, just put it once. Alright. So yeah, this is kind of hard. A little bit hard. The other class did okay with it. Or they didn't complain too much, let's put it that way.